So if we want to sketch a graph of a function, we could always start with a couple of concrete points. You can make an x and y table, plug in a value for x, see what it spits out for y, and that'll give you an ordered pair that's going to be on that graph. The classic one to plug in is to start with x equals 0, because if you plug in a 0 right in there, anything to the 0 power is 1. So let's try a couple other nice and safe ones. Let's try a positive 1 and negative 1 for x. If you plug in a positive 1 into that function, 1/3 to the first power is just itself. So there we go. 1 comma 1/3 is a dot. Now this negative 1, though, you might not be aware of. This one's actually just going to be 3, because a negative exponent can be rewritten as a positive exponent if you make it its reciprocal. So 1/3 to the negative first, that's the same thing as 3/1. So that's what it looks like if you put it in as a positive power. And we all know 3/1, that's just 3. So since negative helped us out, let's try another negative 1. Maybe we can get a nice clean dot out of that. If you plug in negative 2 in here, that's supposed to be a 3. That's the same thing as 3/1 to the second power. So that gives us 9 for a dot. So it's this one, I mean, it's still a dot on the graph, but it's hard to graph. Let's graph this one, and this one. There's the dots when I plugged them. There's 0, 1, negative 1, 3, and negative 2, 9. A flawless graph. There's a sketch, and I'm drawing it as an asymptote at y equals 0, because you can never make 1/3 to the x equals 0. There's no way to make y equals 0 here. You can't plug in a value for x to make that equal 0. So that's our graph. Now we can answer their questions. We need the domain range. We need whether it's increasing or decreasing. The domain represents all the x values that work in the function. So there's no problem with plugging in any x values. You can't square root a negative. You can't divide by 0. So no problem. We're going to say the domain is negative infinity to positive infinity. Let's check out the range. The range is all the possible y values. So this one's easily done graphically. Like, we can't have y equals negative anything. There's nothing in the negative section. We can't have y equals 0 because we said it has an asymptote. We can't get out y equals 0. But every other number greater than 0 works. So when you define the range, you start with how low it can go, and then end it with how high it can go. That's our domain and range. And for whether it's increasing or decreasing, interpret a graph as you read a book, left to right. So it's definitely going down as we read that graph left to right, so it's decreasing.